Hello friends and hello student. My name is Ashok Sijala. In this session, we learn the quick shot in data structure. So let us start. First, I share my laptop screen and fix the position here so you can watch better my video lecture. So here we can start the quick shot, but I first uh, that our previous my video lecture, and that is a merge shot. I open and one that is we cannot use as a free function, because free function is must be when we can use malloc or calloc or realloc function. So that is a file name is a merge short, yes, mer short, and you can look, that is my previous video lecture, but that is I not free. So here that is you can look x, y, and z. So there are three pointer variable and we can use as malloc. So here that is our responsibility that we can use as a free function. So I correct that. So here x, then yes, I copy and paste. So that we have to change. Yes, that is a here y and here z. So now that I think I already, so now I compile. Yes, there is no any error. And we can give the size, that is first x 1D array. So yes, I give the any randomly element, and that is not shorted. And now second, that is a while list, that I again give the 5 element and give the yes, here I give the 2 digit. So yes, sum is a 1 digit also. So 8 is not in above list. So and 9 is there. So 4, yes, 4 is not there. So now what to do? So yes, 10 I give length 15. So you can look now. So that is a merge shot. Two first unshorted list is shorted, and that is combined, mean merge. So that is a third one-dimensional array, and that x, y, and z. So that correct this program to just only free function, that I missing that video lecture, so that I correction in my program. So you can also watch that my previous video lecture. I explained the all about that is merge shot. So now I close, yes, and now I quit also. So we can first cover the quick shot theory. In this video lecture, my goal is quick shot, and we can different between what is quick shot and merge shot. I also cover that. So first I open my book, and that is third chapter 3.5. And quick shot is very faster shorting technique, and it is a most popular shorting method or technique. Method also word used. So quick can short a list of data element is very efficiently faster than any other common sorting method or technique. So it is the most popular, and that is very fast, and that work on divide and conquer rules. So that you have to, that pivot element we have to decide, and then left and right comparison. So that is a work. So this is a short of two small array in then one larger list. So that divide two partition. This technique main base is divide and conquer. So that is a British rule, divide and conquer, and we can use in quick, and that is a only possible recursion. So you have to know function call itself, that known as recursion tech function. So quick short is work as first you can divide define as pivot element, and most of cases first left element defined as pivot element. After that is a fixed place of pivot element using the two rules. So right to left search smaller element compared to the pivot element. So right to left, yes. So we can go the right to left and find the smaller element, yes. And left to right search larger element compared to the pivot element. So there are two rules. So that base of we can define that our position of pivot element at two partition. First partition is a uh, right hand side pivot element greater than element, and left hand side smaller element. So ultimately they'll divide the list in two part. So if it is found, then swap the smaller element or larger element place of pivot element. After apply these rules, all large list divide in two smaller lists. First list is smaller compared to the pivot element are placed as left side of pivot element, and second list is larger compared to the pivot element are placed as the right side of pivot element. After fixed value of pivot element, apply the same rules of two list. So that is a define that pivot element and that left and right. So pivot element is a middle, and that is a right side is larger element and left side is a smaller element. So we can divide in two partition, and again same rules you can apply. So and you can say that is a uh, at the last you can find whole list in sorting, ascending or descending order. This concept is based on the recursion technique, recursion logic. And quick sort is also known as a partition exchange sort. Yes, partition exchange sort, that known as also the quick sort process can explain with the help of below figure. So you can look, that is our list of array, and that I take as 8 element. So 0 to 7. So total number of 8 element. Yes. So first leftmost here you can say that is a 8 element, and 6 is our pivot element. So now we can search first right to left and find the smaller. So you can look here, 10 is greater than to our pivot element, 8 is greater than, but 6 is smaller. So we can exchange that position. So 6 is come to here and 5 come to here. So then again, yes, now I directly explain, that is a all paragraph, that is same I explain. So again we can go, yes, is left to right and find out the larger element. So you can look here, 5 is small, 2 is small, 7 is larger to our pivot element. So that is exchange, and that you can look here. Now again we can go in the right left right to left. So here smaller elements, so 4 is smaller, here 10, 8, 7 all are greater. So we can right to left find the smaller. So that is exchange. So you can look now what is there. So our pivot element now is fixed here, all part sub array 1, and that is all are small element, and here sub array 2, that is all are greater element. So again, that is the same here. You can exchange that sub array 1 and sub array 2. Same rules. First, that is a pivot. So again, you can go, yes, that is a smaller. So that is exchange. And then here 2. So yes, that is a 2. But that is a, we can find larger. So 5 is placed to here and 4 is here. Now 4 in 2, that is we can exchange over 2, 4, and 5. That is perfectly. Now same rules here. So 9, and here we can find the smaller. So that is a we can say that 8. So first 8 and 9 swap, and then again we can go the larger, but here that is only 7. So that is a not. So that is the same rules we can apply. Yes, and then again, yes, here we can go. So our 8 is here and 9 is here. So we can find the smaller element, but here that is a, but 7 is a here, and 8, 10 is remaining here. So that is a 9 is perfect our position here. 8. So 8 and 7 compare. So 7 come to here and 8 to here. So all list is shorted. So you can look here. So sub array with all elements smaller than pivot element, and that is a larger. So now you can look, that is the same rules. So you can define your sub array 1 and 2 also pivot element, and same rules left to right and right to left. So right to left you can find the smaller, and left to right you can find the greater or larger element, and then swap. So yes, that is very faster sorting technique. This sorting technique handle the large list. And disadvantage is, it is this sorting technique require complex algorithm, because recursion is a base of the stack algorithm. So you can understand is very not easy compared to the other sorting technique. and it is recursion function sorting technique, thus not easy understand at first time. Okay, then I take the program, and then that is a our algorithm, and then I also take complexity. So you can look here, quick shot, worst case, best, average case, and best case. So log 2n, that is our best case. And then I cover also merge shot and quick shot, that is a different. So that is a point you have to remember, two, one or two. So this sorting technique use two sorted list for sorting, merge shot. And this sorting technique as only use one sorted unsorted list. Here sorted list two require, and here only one unsorted list is required. Then type, the sorting technique is slower than quick sort. Yes, this sorting faster than all other simple sorting technique. Start, in this sorting technique is comparison start with, yes, so that is a merge sort, both listing zeroth element. Yes, and this sorting quick sort is work as first you can define your pivot element logic. So yes, here in this sorting technique, both simple as well as recursion logic. In this sorting technique, use only possible recursion logic in quick sort, and slower or faster. This sorting technique is slower compared to the quick sort, and this sorting technique faster compared to the merge sort. And popular, yes, that is a quick sort is a so very popular. This sorting technique is not popular compared to the quick sort, and this sorting is very popular compared to all sorting techniques. And then example, so that is a 7. Yes, now shell short is coming, but now I cannot cover the shell shot, but our target is a quick shot. So now that we can understand what is a theory base in that video lecture. So now I open the Turbo C++ and we can apply the recursion logic in quick shot. So yes, so first I yes file menu and take new file, and here write yes that is my uh, we can write the definition in document section. So write a program to perform, or you can say that implement quick, yes, quick shot. That is our target. So implement or write a program to perform quick shot. Yes. Now what to do? So yes, first we have to take, yes, here our first define, that is a header file. Yes. So it is a link section, and that is yes that is stdio.h, then we can say that conio.h, and then we can define the recursion that function is required. So that is must be we can use as user defined function. So first is that is a void, and we can say that quick short. So I say that q short, quick short, and that we can pass that are three arguments. So first is our array, then two boundary upper and lower. So that I not declare any variable name. So declaration time, that is variable name is a optional. So why we can provide, yes, you can also provide, there is no any error. And then second, that our UDF, that is a partition. So that is a partition exchange technique also known as. So I give the partition, so that return data type. So here with argument but no return value, and here with argument with return value. So here we can again pass, yes, that we can partition. So integer, yes, and same that as above, three argument. So that two user defined function, and now our come to main, and first we can scan, yes, first we can declare variables. So asterisk, yes, I directly use the malloc or dynamic array, and then n size and I, there are three variable is required. And now we can provide first, that is our size. So we can say that enter 1D array size, that type of message. And here only one array is there, so no first or second, that because in that is a merge short, we can do unshorted and then we can short. So here there is only enter 1D array size, or you can also that enter X array size, that type of message. So that is yes, perfect. And now what to do? So here we can scan yes n. So first is size, and then now what to do? So here we can use as malloc, and then n multiply size of, that is a operator, and we can pass the integer data type. But malloc function return data type is a void pointer, so we can must be typecasting. So you can understand that is a typecasting. So because malloc function syntax return data type is void pointer, so we can pointer which type is hold pointer variable. That same type we can typecasting to here. So here is character, so here is also character. Here is float, so here is also float. Here is double, so here is double. Character, so character. So any data type that pointer hold, that is same that we can typecasting, and also same in size of operator, same data type. Yes. And now we can require one more header file, and that is a, you can, there are two header files. So allocation alloc.h or stdlib standard library. So I use as alloc.h. And now yes, we can give again message, and that is a, we can say that enter 1D array elements. Yes, that type of message, and we can provide /n, and now we can take one for loop. So that is a I. So here only three variable. Yes, pointer, n, and I counter variable. So I equal to 0, I less than n, and I plus plus. So that is our input. So yes, you have to know, and that I always in array print with index, and scan with index and print with index. That is so you can take which element store in which index, that you have to recognize. So that is better. And now x of I, so that is our scanning is complete. So now what to do? So yes, here we can call, yes, so quick short, that is our function UDF name, and we can pass x, yes, then 0, so that is a lower boundary. So we can compare and define to our pivot element, but here first we can pass x, and 0 0 means lower boundary, and now upper boundary. So lower limit and upper limit, that we can also that n minus 1. So because index start with 0, so I directly pass the 0, and here we can pass the larger our index. So that is index, lower index, and lower boundary, you can, that type of word is also used, and here upper boundary or upper index. So n minus 1, because index start with 0, so you have to understand. And now what to do? So yes, that is a, we can print also here in main function, we can print our shorting. So here we can give after shorting, yes, that is after shorting 1D array elements, yes, elements are, that type of message. And I not provide the /n because we have to in printing time, yes, so that I, and I, that is I plus I equal to 0, I less than n, yes, and I plus plus. So that perfectly, and now we can print, yes, same, that our that shorting. So that percentage d, and I also print the index first time, then after we can remove also. So without index we can also print, there is no any problem. So yes, and that I provide the /n. So perfect. And now yes, I use as get ch, but after printing I now use as a free function. So pass the x. So after printing, so first I save that file. Yes, so what is a, give the name? Yes, that is a quick short. So quick and short, but you can look here more than 8 character, that is not so automatically truncate. So I remove this QI, yes, QUI underscore short. So 8 character maximum we have to provide. So yes, perfectly save. Now I think you have to understand. Yes, understand. So what is a this? So yes, here we can input. That is our input, and that is a our output. Yes, here our output, and in between our logic, that is a quick shot we have to call that our so we can separate to our logic in UDF, and that is a recursion technique. So function call itself, and then ultimately all list is shorted, and we can print directly to in main, because that is a pointer. So indirectly, directly, so indirectly that print all the element, directly that not print. Yes, that my saying. Okay, now what to do? So we can define just definition to our first. That is a, we can say that that is a declaration. Yes, and that is a also declaration. You can also directly write to one. That is a three main part in user defined declaration. Then inside the main is calling. So before the main, that is a declaration. Inside the main you can call, and after the main complete, that you can definition. But you can directly write the definition to here before the main. So that declaration is not required. That is optional. But I not directly take that short technique. So I my you can see in my C language UDF one video lecture that I explain all about what is UDF type of all UDF one lecture. I cover all the user defined function, how it's work, and all type I cover. So yes, that is a user defined function. Yes. So there are two main category: inbuilt function like printf, scanf, that is inbuilt function, like here malloc, free, all are inbuilt, get, ch. But that is a q short, that is our user defined function. So yes, that function data type is void and q short. And now here we can compulsory define to our variables. So I define x, same that pointer. You can also give some different, and that is a LB. LB means lower boundary. Just that I give that name, short technique, short name, variable name. You can give the meaningful name, not any like that depend upon your requirement. So here LB means lower boundary and UB means upper boundary. So here that is the index is 0, and here our index. So large index, yes, LI and UI. You can also provide that type of variable name, but that is a better LB and UB. So lower boundary and upper boundary. That is a I give the meaning of variable. So to take the variable as meaningful as possibility, and you can apply the rules of variables. So yes, upper UB is greater than, yes, always that possible, and LB. So that is a large index, and that is a 0. So that is a if condition is true. So now what to do? So yes, we can start as recursion. So we can first I take, that is a our pivot element. So partition. Yes, I now call this second UDF, and that is a partition. And we can pass X, that is our array, and then LB. Yes, that is our lower boundary LB, and then UB upper boundary. So that partition is defined, that is our pivot element. And then again we can call, that is a quick short. So that now start the recursion technique. So LB, that is a lower boundary, and we can I minus 1. So that is a left hand side we can minus, yes, and right hand side we can plus. So our pivot element in between that is a means larger and smaller. So before that our pivot element, that is a before is smaller list, and after that is larger list. So I minus 1 lower boundary, yes, we can minus index, and then here we can take as plus. So again, second time I call the same process we can define in our pivot element. So I plus 1. Yes, and now we can pass the, here I change the sequence, so you can look here. So here we can pass the lower boundary, and I minus 1, and here I plus 1, and that is a upper boundary we can pass. So that is a very important. So that is a recursion technique function call itself. So now, yes, I save that file, and we can define that is our integer and partition. So yes, is a UDF again, and that is a integer X. Yes, I define, and that I give the LB. Yes, that is a first at LB. Same, I give the name variable and UB, upper bound, lower boundary, and upper boundary. And now what to do? So we can define some variable like I. Again, I define. You can also declare in global declaration. Then P and Q I give, and temp is our swap function we have to. So P we can take LB lower boundary plus 1, because index start with 0, so 1 plus, so over that is a we can define, because that is a pivotal element is 0 index and 1 plus, so that we can P and Q comparison. And now I Q as directly take as upper n minus 1 index. And what is our pivotal element take? That is the I. And directly I pass that is a X of LB. So that is our pivotal element store in I. And now we can start the while loop comparison list. So yes, q is greater than, because that is a store. Just in that is a in your mind, why not take directly this LB and UB in this variable? Because P we can take LB lower boundary plus 1, because we can store as a first as a I in the pivot element. I is our pivot element, 0 index, and P is a next element, and Q we can take because we can again that is a recursion technique, so we cannot change our main element, so we can store P LB plus 1 and Q upper UB upper boundary. So that I take the different P and Q variable to in our partition function. So because that is a recursion technique, after that is a again call that function again and again. Okay. So now here Q is greater than or equal to that is a P, because Q is a upper boundary and P is a lower plus 1, then that is a next element to our pivot element. And now that condition is true. So what to do? So we can again take one while loop. So yes, now we can start our comparison. So X of P, yes, that is X of P, lower boundary less than our pivot element. So that is a lower boundary. Yes, we can left hand side that is go and get the smaller element. So we can index is P plus plus. So you can look here. We can search the lower element in the left hand side. And now again we can take as while loop, and now we can go as left hand. First we can go in right hand side, go to smaller element. Now we can search as larger element to our pivot element. So we can X and Q directly I pass, that is a index, that Q index work. And now what to do? So we can take as greater than pivot element, and then Q minus minus. So that is a, if our pivot element is greater than that element, so in left hand side we can index is minus minus, and right hand side we can plus plus. So that is a perfectly. Now what to do? So here I take if condition. So again same, Q is greater than equal to P. So what to do? So if that is a possibility, means that all index is so we can use as a swap. Yes, that is we can exchange to our pivot element. So first I take as P X of P in temp, and now X of P is free. So I give the X of Q larger element, and then yes, X of Q to our temp variable. So that pivot element is shifting. And now at the last, yes, that is a if greater or smaller, so that is left side. So we can say that uh, right to left we can find the smaller smaller element, and left to right we can find the greater element and then swap to our pivot element. That same logic we have applied, but at the last we can exchange to our pivot element to the middle part of that partition, because that is a partition. So exactly that divide in the middle part to our separate set to our pivot element, and all smaller element is a left hand side, all greater element in the right hand side. So I think I explained to you. So I think you have to understand. So what the condition? So yes, here there are, I think we cannot take any condition. We can directly temp, yes, temp, and that is, we can now I use our original. So LB, so lower boundary, that is I store in temp, and then LB, yes, I define, that is a, we can say that is. So now you can look here, I use one upper boundary and directly Q. So because why I use LB? So LB is a directly original. So that is a 1 plus is not required, because that is a our lower boundary, and Q I use as a, that is Q element, not upper boundary element. So we can exchange to our pivot element exactly to our middle position. So these three statements swap to our pivot element at the last. So I think you have to understand. So X of Q, and now we can assign the 10. So that is a very important, these three lines. So yes, we cannot directly understand, because that is at last time at that position that is happening. So we can watch window apply, and then we can understand why I provide this type of three statement to here. And here you can observe LB, and that is Q. We can see that is a both in. So, and now at the last we can return, because here that is a return statement is required, because integer data type is required. So yes, we can return, and that is a Q. Yes, return is a Q. So yes, what is Q? So that is ultimately that change and that partition as middle part of our element, and here that defined to pivot and then quick short means that recursion technique. So that not easily we can understand, but we can use as watch window then, and then we can understand this logic, how it's possibility. So directly I not to if you convey understand directly what is exactly happening. So let us first correction of our logic or not. So first I compile, yes, I save, yes, save, and compile, yes, there is so yes, here semicolon is required. So there is no any error. It's only semicolon that I typing mistake. So yes, let us check. I run this program, and that is our my book. First I take, that is our element. So that is a perfectly I take the element. So which type of element I input and output. So you can look here. So yes, first that is our. So I give 8 size and 6 to, yes, I write somewhere. So that is I write. So that I input that type of element 6, 2, 7, 4, 9, 5, 8, 10. Yes. So perfectly. So now perfect. I remember this element, and I come back to our editor and compile. Yes. And then run. So I give the 8 size and same element to in my book. So 6, then 2, then I think 4, yes, 7, then 4, yes, then 9, then 5, yes, 8, and 10. So you can look, yes, perfectly. So 2, 4, 5, 6, 7, 8, 9, and 10. So that is our 8 elements. So you can look perfectly sorting in ascending order. Yes, perfect. after sorting 1D array element. So how it possibility? Yes, that is a here. I think you have to understand. So which logic, how it possibility. So let us take. We can that not directly this logic we have to understand. So I trace not all program because that is very long, but we can take some partition how it's works. So first our pivot element how it defined, and left and right, and how fixed our pivot element position. So you can look here watch window, and again I alter W and take as output window. So you can look here our element, and now I take this screen some shot, and here we can define. So yes, here very important. So ultimately partition function we can take in our watch window. So first, yes, that is a we can take as P. Yes, that is our P separate, then Q, then I. And now what to do? So yes, X of P, what is that is happening? Or first, yes, I also take and P of I, and then it is a we can take index. Yes, we can use as variable, and P and Q also use as index. Okay, now what to do? So yes, that's sufficient. So yes, I directly start to watch in our quick shot, means here. That is our quick shot. Yes. So I control F8. Yes, that start to watch here. And now again I control F9. So run over. So I give the 8 element and same over 6. Yes, that is I define the pivot element. Then 2, 7, 4, 9, then 5, 8, and 10. So element selection is also important in this quick shot. Yes. Now you can look here. That is a waiting, and I press Alter R. So you can look here. Press into F7 function key. I press. So that is a quick shot. You can look here. And yes, first I also here write that is a so it is a we can say that LB, yes, and UB, that is our also variable. So you can look 0 and 7. So 8, yes, here you can look here. I enter n minus 1 because index start with 0. So upper boundary and lower boundary. So 0 and 7. Yes, you can look here 0 and 7. And now you can also take 0 is our 6 element, and that is a 7 index is a 10 element. So that also you can watch in our output window. Yes, now that is our quick shot is means that function is called, and you can look here. So yes, 7 is greater than 0, so condition is true. Now 8, yes, that return is a q in the partition function. So that is a define the partition. So sub array 1 and sub array 2. So in my books you have to, so you can look here. So that is the same copy LB and UP 0 and 7. Yes, same. And now what to do? So LB, yes, that is a lower boundary plus 1. So that is we can store in the second. Yes, here you can look here index 2. So that is index is plus. So P is start 1 and Q is now 7. You can look here now 7. So 1, 0 is our pivot element. So I LB plus 1 in store P and Q. So that is also P and Q is index. So we can use in the lower and upper. So P and Q. Now I, yes, I directly I use LB. So that is a 0. You can look LB is a, again same 0. So that store our 6 as pivot element, and that is now we can P Q is greater than P. Yes, that obviously P is 1 and Q is 7. So that condition is true. Now you can that is a we can search our element. So here that is a P of I is 2, and that is a less than of I. I is our 6 element. So condition is yes, that is here is a 6 and here is a 2. So yes, that condition is true. So that index is P is plus plus. Yes, you can look here. just we can take this while loop p is a plus plus. So we can search as our element in the we can say that that is a 2 here, yes, and here is a 6. So p is starting to our first part, so we can find that is larger element but that is a smaller, so we can index is plus plus again. So that loop is continue, you can look here, p that is a plus plus. So now that is a 2 7 and that our element is 6, so that is a complete. So our index p is 2, you can look here 7 element, but that is a greater to our pivot element. So now that plus plus is complete, now minus minus, so fix to our pivot element position, that is our goal. So we can directly not swap, yes. So here at q, yes, q is where, so q is 7 and that is a last is our element in that output. You can look here, that is a 10, yes, I scan as a 10 element. So yes, so that is now that perfectly. So I, yes, you can look here 10, yes, I just show you. So now what to do? So yes, here that is a our, yes, now compiler is come to here, yes, now I take that position and 10 is greater than I, yes, I is our 6 and 10 is greater than, so q minus minus, yes, you can look here, q minus minus, so q is 7, now that element is 8, you can look here 8, so 8 is greater than 6, yes, that is q again minus minus, and then here now what 5, yes, but that is a false while loop because 5 is not greater than 6. So yes, here now exchange, you can see that q, yes, q is now 5 and p is 2, that again condition is true, and now our that is a p is holding 2 and q holding 5, so that is exchange. So you can look now swap is possibility. So again that while loop is come to picture. So that is a fixed to our pivot element. That is a main while loop, and that index this two while loop is that I p plus plus and q minus minus. So lower and upper. So lower boundary we can take in p and upper boundary. So upper boundary minus minus and lower is plus plus. That of meaning. So now again you can look. So our pivot element is a fix. That is a you can look, that is I remaining 6. And again compared to our pivot element, P is now that is a index, you can look is here 2 and element is 5. So 5 is less than, yes, 6, so that is p plus plus again. Now what to do? So yes, p is holding 3 and pivot is again p plus plus, so that is a 4, and now our element is p4, 4 is 9, so now condition is false. And here that is a q, q is greater than I, so q holding the 7. And here I is 6, yes, again that minus minus. So now here q is taking position is a that is a 9 and our pivot is 6, so that while loop is false. Yes, no, true, because 9 is greater than 6, yes, that is minus minus. Now that false because now holding that is a q is 3 and 3 index is a 4, so now 4 is not greater than 6, so that is false. And now you can look, that is a q, yes, q is index, that is a here 3 and p is 4, so that is if condition is false, so that is a our lower means we can say that lower boundary is 4 and upper boundary is 3, so not p is q is greater than, no, because that is a 3 and p is 4. So now yes, here also while loop is false. So now we can turn, yes, why I taking this, so you can look now our pivot element now that is taking to fixed position, and that I show to in my book. You can look here which index first I set. Yes, you can look here. So first all that first round is complete. So that index here 0, 1, 2 and 4. So you can look that first 6 is set to the 4. So now, yes, that is a, we can say that temp, yes, here 0 is stored into the temp. And now you can observe how that taking the pivot element. So yes, that temp is taking, yes, I just write the temp variable also in our, so temp is taking 6 or pivot element. That is a LB, and now LB turn to Q. So Q is which element? So Q is holding, that is a T. Yes, here that is a index 3. So you can look here, that is a position now exchange, because that is a swapping. So here that not means that is our element index is 3 and 3 is stored to 4. So yes, I just let us check. So that Q, yes, here that store in that LB. So first taking that is as 3, and now temp assigned to Q. Q is which element? So index is 3, and that is a exchange. So here that come to 4 to 6. Then Q is written. So Q is which index? That is our first partition, and that is a position of 3. And now again that you can look here. So that is a now turn to recursion is start. So first swapping. So here very important. You can look here. So first our partition is defined to our first our exchange that element. So yes, I think you to understand. So first our pivot element exchange to our lower boundary and taking that position. So that is not easy way I explain to you, because that is a recursion technique now start. So yes, let us check how it possibility. So yes, again here that is quick shot. So I minus 1, and then here uh, x again and lower boundary. So I that giving to q, and what is our I is 3. So that is index we can store in I, and we can pass I minus 1. So that is a second here. So yes, that is a source is no, yes. So directly that start, yes. Here again same process. So now I cannot repeat because that is a very long. So again you can look here that index is store and lower and upper boundary, and our pivot element is defined is 4 now, and that same plus plus and minus lower and upper, and then exchange that all part. So that is now recursion is start. So now I finish because that is a very long session is there. So yes, first we can define to our pivot element and then partition, and then we can same logic that partition sub array 1 and sub array 2. So upper and lower boundary is very important in this session. So now I just remove that is a red line that we can start watch window. So control F8. So now I hope you can understand, because that is a recursion technique, not the easy way. That is a maintaining the stack algorithm, and then all are pop, push and pop. That is a push means insert and pop is delete. So that is a making the stack algorithm. So yes, I hope you can understand and enjoy. Any question regarding this logic here? I very simple way understand to you how that recursion is work. So that based in the stack algorithm. So at a very important this session, that is a quick shot we can apply to very only taking two user defined function and nesting. Yes, here we can call the first is quick shot, and quick shot call the partitions to decide to our pivot element position, fix the position. Sub array 1 and sub array 2, and same process to sub array 1 and sub array 2, left to right and right to left. So left to right we can find the smaller element, and right to left we can get the larger element to our compared to our pivot element, and then partition. So that word we can say very easily, but understand of that logic is not very easy way, because that is a recursion technique. So ultimately, at the last, we can exchange to our pivot element and return that index. So now I hope you can understand. So yes, now I close. So write this program to your C TS, not but that is we can use as C programming language. So you can write in data structure. That is a quick shot. So next upcoming my video lecture, I cover the shell shot and only one and bucket shot. So there are two shotting. So selection shot, yes, I bubble shot, insertion, and that merge and that quick shot. So now I take that is fifth technique. So all 5 video lecture you can watch one by one, step by step. Yes, now I close these files. So very important and very simple way I can explain or develop this logic very easy way. But you can try to watch window to yourself and some paperwork, then and then you can understand perfectly. So I try my best level, but I think you have to not understand as to your requirement. I think so. I hope you can understand. Yes, I close Alt F3. Yes, watch and output and all, and then you can quit. So yes, subscribe my channel Ashok C Jalakadi and press the bell icon to never miss any update. Thanks for your watching, supporting, and sharing my video lecture. And Hare Krishna.